Okay, today well, technically chapter 16, but we are going to start talking about searching and sorting, which is very common, operations that you perform on data. A lot of times you are having, you have a bunch of students and you want to search for something, and it can be helpful to sort them first, as we will get into, because once a group or an array is sorted, you're allowed to do a far more efficient version of searching, and we will go over those two today. That's nice. Oh, that's nice. Yeah, okay, good. Sequential search. So let's go and jump over on our sequential search, and we're going to at least start with an open. Let's go linked list. That sounds great. We'll call it 08 search sort. Now this time I'm not going to be doing the unit test because it makes a little more sense to just try to write it out, and so we can play with it. So if we want to search for something, and we hopefully did this in your lab, if we want to do this, let's see, it was int, or actually contains. Let's do contains. We'll do int star array, and then constant int size. And then if we have an array, oh no, bless you. I'm becoming very uninventive. And let's see. We gave it the array and the size, but we didn't tell what to look for.
Should we be seeing stuff on our sandbox?
Yes, you should. Do you not?
I have student sandbox, but no.
Did you tmux ATT?
Oh.
How many values are in here? Let's see, 1, 2, 3, 4, 5, 6, 7, 8. And we're looking for 100. Alright, let me go ahead and make a new one. There we go, class code 08. We do a quick make. Ooh. Probably should put a semicolon there. Make it real quick. Alright, make and main. Well, returns a negative number probably because we haven't implemented the function. Alright. I know it's Monday morning, but can someone write that real quick? AK, you're returning true, AK 1, if, oh wait, this is C++. Hold on. Perfect. You're returning true if the val is inside of that array. All right, y'all got this. Alright, that looks pretty good. Let's see. Returns 1, aka true. And actually, let's do this. Let's do 10. it'll automatically run a bunch of them. So 1, 2, 3, and 8 are in there, and the other ones are not. Okay, great. What is the big O of the contains function? O of n. All right. So, well, these numbers, though, are in sorted order. Is there any way we could take advantage of that?
Almost certainly.
Almost certainly. Since your professor is asking. Of course there is. Anyone want to take a guess?
You could start at the halfway point.
Start at the halfway point. All right. All right. How do we do that? Let's make a separate function, right?
Yeah.
And we haven't given a name yet, so we're just going to call it contains faster. It's just the faster version. Well, you said check the halfway point, right? So let's just do that first. We'll start at control. All right. What's the halfway point? Yeah, I type tour all the time too. All right. Okay. Well, it's definitely not guaranteed to be there. So, what do we do next? Yeah, less than. I like that. Less than val.
Just send the thing what I'm asking it to do.
Yeah, well, let's just write that out real quick. So, yeah, so then now we can think about, well, if it's less than val, what do we want to do? Do we need to search the top half? No, we only need to search the lower half. Do we have a function for that? All right. I'm just going, anyone see the minor error?
Yeah, just view.
I'm trying to get everyone else to wake up. It seems like a rough morning for some reason. Is the rain getting you down?
Possibly.
Possibly.
It's not supposed to be both hot and rainy at the end of September.
True. I don't know if it's that. Wait, is today the first day of fall?
Yes.
Nice. All right. Although summer wasn't too bad this time around. All right, so we have a contains function. Great. But what happens if it's not equal to and not less than val, and therefore greater than val? you want to return? Right. What part of the array are we looking at this point?
Second half.
The second half. How can we make a pointer to the second half? Because if you pass A or Y right now, that's the pointer to the beginning of the array. That's not what you want. You want to point to the upper half of the array. Okay, good start. But the subscripts dereference. So I think you want to add. So I'm going to put in what I believe you meant. So take the array, go up by half. Now we must check. Do we have an off by one error? Well, anyways, yeah, keep going. Okay, so let me run this real quick and see what it gives us. Do the same thing. We also probably should call the faster version, right?
Yeah.
Whatever. Or, you know what? We do this. That way I won't have to retype it. Oh, we failed.
Yep, I knew it. I was thinking, I think I got the sign wrong on the else if. It was supposed to be greater than and not less than.
Yeah, so if it's less than, yeah. All right, go ahead. Hold on, if it's less than val, right. If it's greater than val, then you want to search the bottom half. There we go. Yep. I think that was what it was beforehand. Great. There's a couple of errors. Let me think here. Technically that'll work. All right, so I'm going to do a little code cleanup, and tell me if you agree or disagree. So this thing up here is really a guard if statement saying that if this happens, jump right out. And since we're jumping out, we don't need to put an else there. We just need an if. This if statement's returning immediately, so we actually don't need that else either. We can just leave it like that and the code still stays the same. The reason I suggest doing it this way is it makes it easier to read. I have students that make the flying V where they have all these if statements, but if you can say if this return, that return, then you're basically validating until you get to a certain spot. So in general, this code is considered a little easier to read. Now there's still some issues with this code, and we'll get to that in a moment. Now, although I do find it, let's see. So this at least jumps in half, but then does a linear search of the top half or the bottom half. So what's the big O of this function?
Oh, log n.
No, it's doing the linear search of half of it. So 0.5 of n is still O of n, right? But you're on the right track. What function should we be calling?
Oh, faster.
Faster, yes. I put you in insert mode. Oh, there you go.
I use VI. I know how it works.
Oh, sorry. Most students, yeah. There we go. Against faster. And let's do the other one. Fatser. All right. Let's save that. Jump over here. Make Ooh, seg fault. Classic. All right. Let's see if Valgrind will help us out. Ah, process terminated. Wow. Stack overflow. Oh, can't grow. Okay, so we had a stack overflow, meaning that we kept recursing. Uh-ohs. All right. Well, if we kept recursing, we're going to need to figure out what's causing us to keep recursing. So let's go up here and do a little print out. Let's say size equals %d and ARY equals %. Wrong language. No, size is 0. It just keeps going. What should we do?
We should move the statement that catches.
You got this. In that curly bracket. All right. Ooh, double in. Great.
Extra emphasis. I'm sure the computer will read it that way.
Won't be a problem. All right, so let's comment that out. Let's run it now. All right. Hey, that actually looks like it's running. Cool. Well then. Are there any issues with this? Well, none that are popping out right now. But there could be. How many elements are in this array? I already forgot. 8. Let's make it a 9.
Yep.
Because 8 is a nice number. What did I do?
It's not necessarily something you did.
It's not necessarily you, Dr. West. What did I do? Okay. Hey, that seemed to be fine. Let's see if we can find all those numbers. That'd be handy. Oh, I don't want to type this out. Let's see. 7? Actually, let's see. Is there a better way to do this? Nah. $78, 100, 2, 1, 3, 0, 5,000. 78, 100, 2, 1, 3, 0, and 5,000. Oops, 5,000. Let's see if it likes that. Didn't find 5,000. Did I give it the right number? Let's make sure. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 0 to 8. Yeah, so 9's in there. Uh-oh, it didn't find the last one. Let's see if the other function finds it. It does.
It didn't look like it.
What's that?
I didn't think it did.
Oh. Run it again. Contains array 9 5001.
Wow.
Faster 0. So it doesn't like it when it's the max. Although it found 1, didn't it? Let me find out. Let me look real quick. Yeah, contains faster. It finds the first element just fine, but not the last.
It doesn't like integer division, so it's just truncating it, so
Yeah. Ooh. How do we fix that?
right ways we can check if it's even or odd.
If it's odd, check the last one and then run the program. You know, that will work.
This is clearly not what you want, though.
That's not what I was thinking, but that will work. Sure. All right, you want to go do that? I mean, I'll accept that because it's going to solve the problem. It's not the way I intended it to be solved, but it's okay. Well, the other problem is, if it's not a power of 2, you're going to keep hitting an odd number at some point, right? So I don't know if you just do one check for odd. You're going to have to be checking almost every time, and then that's going to degrade performance. So yeah.
Could we just set size to be an even number?
Solve the problem of making it never happen. Or you mean by ignoring it? No. No. We'll copy all the contents into an array of a power of 2, filling in the extra values with numbers that are not val, and then run the program. All right, let me at least try and help you out a little. Int mid equals size divided by 2. All right. Sometimes it's helpful if you give everything some names. Okay. Make sure I did that right. So if size mod 2 is equal to 1, then is all this 1, otherwise it's 0. Okay. Y'all familiar with the ternary? Do they do ternary?
Yeah.
Okay, great.
Can you, instead of doing over here, just do,
Insert mode is I.
Yeah.
size minus mid,
Let's see.
and then that would kind of,
So if mid, okay. So if it's 9, mid would be 4. And so you'd be adding 5. Okay. If size was 8, then 8 minus 4 would be 4, you'd be adding 4. That'd be different. Wait, I don't know if that's what you want. Because mid, in both those cases, mid is 4. But in one of them, you're going 5, the other one, you're going 4.
yeah.
I think what might make a little more sense is mid plus 1.
If it's odd, then you do mid plus 1.
Well, if you've already checked for mid, right? You don't need to check for mid again. So, I mean, we're going to have to, whoops.
Oh, yeah.
Yeah. So, and the size will then be mid minus 1 because we need to subtract by 1. Okay. I mean, I think maybe that's more what you're going for. I don't know exactly yet.
I was just kind of trying to.
Trying to, sure. Okay. Okay. Well, maybe it makes some sense if we go up here and we throw some numbers together. So if size is 9, we'll go like right here. Size equals 9, and then mid equals 4, and is odd equals 1. Right?
Yeah.
Okay. So let's see, check this. Size equal 1, I don't think that has anything to do with that. So let's look here. Mid, yeah, we're just checking the mid anyway, so that's normal. Here we're checking if mid is greater than val. That's still fine because we still want to work with mid. All right, here, let's look at this. If the middle is greater than the val, then we want to check the lower half. So we want to start our pointer at the beginning. Do we only want to check the first 4 or the 4 elements? I mean, something of length 4, sorry. Because we've already checked index 4, so we want to check 0 to 3. So size of 4, yeah, that actually makes sense, right? That one makes sense. Okay. And then down here, if we're doing the upper half, then I think we just went through that. You want to actually start at 5, and then, mid -1? Is that what we want? -1?
Yeah, because you have +1 on the other parameter.
Right.
But for the size,
For the size, we want to make sure the size is correct because that might be where our problem is. Because if size, mid would be 3, but we're trying to go from 5 to 9. Yeah, we got off by 1 error. So we don't want mid -1 here. We actually want it to be mid. Okay. But we still want to add 1. We just want to do the top. Because in this case, mid is correct. But we also now need to evaluate the even case. We're trying to figure out, what are we doing? We good? Oh, sorry. That was me. Go ahead. I thought we were doing something else. Oh, someone's jumping, going right to the solution. Nice. Oh, who saw that? Who did that? Nice. All right. We want to add is odd. Let's see why that works out. Or actually, can you explain why that works out?
Well, because if it's odd, then we add 1, and if it's even, we add 0.
Well, yes.
and that's what is odd is defined to.
Right here.
We're almost
It's
there.
1 or 0.
We're almost there. We're almost there. Let's do even. So I'll take this. Oops. Size is 8. Mid is 4. 8 divided by 2 is 4. Odd is 0. Okay, great. This line looks good? Yeah. This one good? Yeah, we're still checking mid. Yeah, we're still checking mid. Okay, here, let's evaluate this real quick. So we're at array. We want to look at the next 4 because we're chopping off the top. Yeah, because we looked at mid. That looks fine. Hopefully. All right, here we go. Array plus mid plus is odd. In this case, it'll be back to 4, and then we want to look at length 4. So we're going to start at index 4. So 4, 5, 6, 7, 8. Uh-oh. 4, 5, 6, 7, 8. No, 8. We don't want to go to 8. We want to go 4, 5, 6, 7. Okay. Let's see what that does. Well, that was fun. What type of function is this?
Is it bubble sort that's on live 09?
No.
Oh, dang. Wait.
No, the slides, I don't know why the slides talk about sorting before this, because it's like, let's just sort something. Why are we sorting it? It doesn't tell you. This tells you why we sort. All right, let me ask a different question. What's the big O of this? You got this, Cleek.
Oh, log event.
A log of n, awesome. And is that faster or slower than O of n?
Very faster.
Very much faster. It is significantly faster. In a way, you could call it exponentially faster because it's log. Anyways, so yeah, this is a whole lot faster than O of n. So we want to be using this function. Now, other thing. This is what I was trying to get at earlier, this is a recursive function. Did y'all go over recursion a little?
We've gone over it a little.
you'll become very acquainted. This is not the last time you will see this. The function is calling itself. When a function calls itself, it is very, very, very important that your first checks are, can I exit this function? Please do it that way. Yes, you can write a recursive function that doesn't do this, but you are going to be sad, okay? You're just going to be sad. Just put your checks up top, aka when do I get out of the recursion, aka if size is 0, we didn't find it. If we're at the value, we did find it, let's get out. All right? All right. But notice after that, it's, I mean, how many lines was it? It was 3 lines after those checks. Of course, it was, I mean, yeah, we had some logic up here to set it up and make things a little more, hopefully easier to read. All right. This is called a binary search.
Oh, yeah, that's the other part.
So I'm going to change contains faster. I'm going to leave it commented out to a binary search. And let's go contains faster. Binary search, binary search. I don't want to do it on all of them, just in case I miss one. Yeah, we don't want that one to be changed. Okay, great. So let's go back and run it real quick. Binary search. Perfect. Okay. And let's go and delete that code right down there. I'll leave these comments down there in case that helps anyone.
Do we actually need the ternary operation thing at the top of the mod? Because it should only be returning 0 and 1.
That's correct. Yes, but I've learned for emphasis for students, it's best if I do that. Also, your compiler can optimize that out. It knows that anyways. So in reality, what he's mentioning is this is the same thing as that. Because this return, when you do a Boolean comparison, it returns 1 for true and 0 for false. So there was no need for me to explicitly state it as 0 and 1, is what he's pointing out.
Oh, you don't even need the equals 1.
That is true too. You actually just need that.
True or false?
So for your loop.
Well, I mean, size mod 2 is going to give you 0 or 1 as well. I just wrote it out longhand to make it clear what's happening. Although modding it by 2 might be very clear for you too. Whatever.
I think I'll be glad to have it like this when I go back and review the class.
Exactly. The compiler is going to optimize it for you. So we're good. But good catch. Any other questions about this function?